Next, we're going to move on to the arc length. So the formula for arc length when we're having a parametric equation is going to be S, stand for arc length, equal to the integral from t1 to t2, which is the interval for the t's, and square root of dx dt squared plus dy dt squared dt. So the formula is pretty straightforward. We're just going to take the derivative respect to, for the x function, for the y function, and then square them. So the example we have is we want to find the arc length of a semicircle defined by x of t equal to 3 cosine of t, y of t equal to 3 sine of t, and t is going to be between 0 and the pi. So to do it, we just straightforward. You apply the formulas that the arc length is going to be an integral from 0 to pi of square root of dx over dt squared plus dy over dt squared dt, where dx dt is going to be negative 3 sine of t and dy dt is going to be 3 cosine of t. Now we can plug in. Negative 3 sine of t squared plus 3 cosine of t squared dt. Nine sine square of t plus 9 cosine square of t. Factor out the 9. Sine squared of t plus cosine squared of t dt. So factor out the 9, and then because of the square root, this becomes to just a 3. And then this whole thing, sine squared t plus cosine squared t, is just equal to 1. So pretty much what we got at the end is just integral from 0 to pi of 3 dt, which is 3t from 0 to pi, which is 3 pi. And then the graph we're talking about, because this is a semicircle, the graph we talk about it is actually from here to here, a semicircle.